I'm Chris Lewicki, and I'm the President and Chief Asteroid Miner at Planetary Resources.
Can you tell us more about Planetary Resources?
Planetary Resources is a company founded to pursue resources in space. We'd like to extend the economic sphere of influence of the planet into the solar system by using resources of near-Earth asteroids.
How far is the closest asteroid?
Asteroids are orbiting the sun just like the Earth. They can be as close as running right into us or passing close by, but they're usually several million miles away. It's not so much the distance, actually, that makes them interesting to us as their energy to get to them. So in many cases, the near-Earth asteroids, as they're called, are actually easier to get to than it is to even land on the moon.
Wow, so how much time do you think it will take for us with current technology to get to an asteroid?
So there have actually been several spacecraft or missions sent to asteroids already. We've had asteroids go to the first near-Earth asteroid, Eros, about 12, 13 years ago. Japanese have sent a mission to the asteroid Itokawa in 2005 and 6. And the U.S. just finished up a mission at the Main Belt asteroid for Vesta. And they're headed off to the asteroid Ceres later next year.
And once they get to the asteroid, are they mining right now, or is that what your goal is, just to start mining asteroids?
So our goal is to find the most valuable and most interesting asteroids and to find where the resources are at. And that really begins with prospecting. So we'll go to likely tens of asteroids to find the best ones, the most accessible ones. And then we'll use what we learn from those missions to develop technology to extract the resources from the asteroid.
So when the Japanese and the U.S. returned, did they bring any valuable minerals back with them?
So the Japanese mission was the only one that actually brought material back, and they brought an extremely small amount of it. And the missions from the government so far have been for scientific purposes. They're interested in learning about the formation of the solar system and very detailed questions of the asteroid's history, and that helps a company like ours very much because we can use that same information to help make plans about future development of the asteroid. So they're interesting scientifically, they're interesting from a resource standpoint and how we can use the materials on them, and they're also very interested because every once in a while they happen to run into the planet and cause a little bit of a problem. And these are all problems and challenges that we have technology now to be able to address.
So with the asteroid that the Japanese brought back, the small amount, why do they bring just a small amount back, and is it valuable?
So they would like to have brought a bit more back. They had some very challenging aspects on their mission. But what they were able to bring back was extremely scientifically valuable. We have many meteorites, actually, that land on the Earth every day that we can study in our labs. But we don't know a lot about their context or where they came from. So by going out to an object, studying that object out in space, and then bringing a piece of it back to study in our best laboratories here on Earth, we can answer some great questions about what that asteroid experienced in the solar system and why it came to be.
What are some of the minerals or metal you might find on an asteroid?
So there's three different types of material you typically find on asteroids. There are stony type asteroids we can just think of as a rock. There are metallic asteroids, which often are composed mainly of iron, and you often see these large iron meteorites in a lot of museums and places like that. And then there are also the carbonaceous asteroids, and like the name says, there's lots of carbon in these, as well as other volatiles like hydrogen, nitrogen, and oxygen. And these, of course, are elements that form interesting molecules like water. As it happens, water is the material that we are interested in first. Water is the essence of life. Water is useful for industrial processes. Water is useful for protecting humans in space. And if you break water into hydrogen and oxygen, you have the most efficient fuel that we've used for rockets to date. And having a fuel source in space is extremely useful for exploring space.
How many months or years was the round trip for U.S. and Japanese missions?
These missions often take many years. You set the spacecraft on its way, it coasts around the sun until it intercepts the asteroid. It spends a number of months at the asteroid, and then it's about the same duration for the visit back. And these are things that we know very well, we can plan for, and the automation on robotics now allows us to actually set up these missions to go forward and largely do their activities without much assistance from humans back here on Earth. And this is exactly how we plan on doing our prospecting and even our mining activities, by using automation and artificial intelligence as this technology advances and gives us much more capability in the robots and their ability to gather information about asteroids.
When I think about prospecting on an asteroid, I think about the movie Armageddon. Are asteroids that size? And would you be landing it on the asteroid, or would it be tailing behind it, picking up the dust?
I wouldn't look to the movie Armageddon for hard scientific fact. I would recommend watching the movie Deep Impact, which is a little bit closer to the truth. You don't so much land on an asteroid as you dock with it. There's very little gravity on these objects, and you can think of it much more like a rendezvous in space. There would be dust, there are materials that are loosely bound together, and working in the microgravity environment is one of the first challenges that we'll have to overcome. But this is stuff that we, as humans, have encountered many engineering challenges, and when there are sufficient motivations for overcoming those challenges, we find our way through that and find design solutions, and that's what Planetary Resources expects to do.
What do you think is the economic gain from prospecting on an asteroid?
So, economics in space are going to be driven by resources, by the real estate associated with those resources, and being able to bring those resources back to a point of need. If it's water for fuel depots in Earth orbit to provide fuel for transportation for a space industry, if it's raw materials for building large structures in space with iron, nickel, or cobalt, or maybe even the very rare platinum group metals, bringing them all the way back to Earth, there are a variety of economic interests for developing these space resources.
And what is your short-term goal?
Our short-term goal is to dramatically reduce the cost that it takes to send spacecraft into space and use them to gather information. We need to learn about asteroids and prospect them and find the valuable resources for very low cost, so that, of course, we can do this economically as a private business.
Now, is there anything else that I didn't touch upon that you'd like to talk about?
We can talk a little bit about, I guess, the gaming environment and why this is of interest to EVE Online folks. We're really seeing the convergence of science fiction and reality, and it's often the case that the future is imagined before we actually create that future. So I'm really excited to come to an event like this, where we have many gamers who are doing many of the same things that we will be doing in the future, except that we're actually at Planetary Resources working on the early stages of making that science fiction into a reality, and I think that's exciting for everyone here.